This video, we're going to talk about exponential functions. So an exponential function is defined to be a base, b, which is just a number larger than 0, but not equal to 1, raised to an exponent that varies, x. And this means if you plug a positive integer in, you get x copies of b multiplied together. So for example, b cubed is b times b times b. So the first property of an exponential function is any base b, which is positive and not equal to 1, b raised to the 0 power is 1. So an exponential function always passes through the y-axis at 1. By convention, negative exponents mean division. So b raised to the negative x power is defined to be 1 divided by b raised to the x power. If you multiply two exponentials with the same base but different exponents, you add the exponents. The reason for this is b to the x means you multiply b by itself x times, while b to the y means you multiply b by itself y times. If you count up the number of b's that you have, there are x on the left, y on the right. There are therefore x plus y b's in total, which is the same thing as b raised to the x plus y power. Combining properties 1 and 2 together, we can see that if you take b raised to the x power divided by b raised to the y power, that's the same thing as multiplying b to the x by b to the minus y. Number 2 says that when we multiply two exponentials with the same base, we add the exponents. X plus negative y is the same thing as x minus y. If we take an exponential, b to the x, and we raise it to the y power, that means we take b to the x and multiply it by itself y times. So arranging y copies of b to the x means in each one of these there are x b's, there are y copies of those x b's, therefore there are x times y b's. So b raised to the x raised to the y power is the same thing as b raised to the x times y power. If we take another base, let's call it a, that is positive and not equal to 1, if we multiply those two numbers a and b together, then raise them to the x power, that means you take ab times ab times ab, etc., x times. Since we know multiplication is commutative, we can rearrange the order. We put all of the a's together, all of the b's together. There are x of each, so that means a to the x times b to the x. So that says ab raised to the x power is a to the x times b to the x. So the behavior of exponential functions is nice. They are continuous functions. They're defined for all real numbers, and they have a range from 0 to infinity. For bases that are larger than 1, to the right, far out to the right, the function b to the x tends to infinity. In fact, exponential functions grow very fast. To the left, exponential functions decay to 0. So the limit as x goes to minus infinity of an exponential function, where the base is larger than 1, is 0. If your base is a number between 0 and 1, the behavior is flip-flopped. So the limit as x goes to infinity of b to the x is 0, and the limit as x goes to minus infinity of b to the x is infinity. This tells us that there are exactly two graphs for exponential functions, depending on whether the base is larger than 1 or smaller than 1. So the first one here is the graph of b to the x when b is larger than 1. No matter what value b is, as long as it's larger than 1, it will always pass through the point x equals 0, y equals 1. It has a horizontal asymptote at 0 because the limit as x goes to minus infinity is 0, and it has no asymptote on the right-hand side because the function grows without bound. When b is between 0 and 1, we simply take the mirror image of this. So when b is between 0 and 1, if we turn this graph around, we just get this. It still passes through 0, 1. The behavior is exactly reversed. Instead of going to infinity as x gets large, we go to infinity as x gets large and negative. As x gets large, we tend towards 0, and we have a horizontal asymptote at 0. One observation that we can make here is in both of these cases, these graphs clearly pass the horizontal line test. If you draw a horizontal line, they will intersect in one place if that line is above the x-axis, and it will not intersect if it is equal to or below the x-axis. That tells us that exponential functions have inverses. We'll talk about those in our next video.